title slide here. That's probably going to be the first of 2 times I'll reference this title, which of course I borrowed from this song, Harder, Better, Faster, Stronger. My name is Niklas, Elmqvist, as you heard. I'm a new professor here in Denmark. I do all kinds of work. I'm a bit of a generalist, that's a nice way of putting it, in data visualization. Perhaps I have a low attention span, that's a less nice way of putting it. I've done work on accessibility, on immersive and ubiquitous analytics, on physical computing, and also data science and data visualization in computational notebooks. This talk is going to be about none of that. Because I have had a problem for about, I don't know, actually since the beginning I started doing this kind of work. And I guess it's a bit of a fear. I think perhaps a lot of this data visualization people are increasingly seeing our work put up in comparison to AI. And to me, as a data visualization person, I've always seen artificial intelligence as the other side of the fence, perhaps a different philosophy of doing, for example, things like data analysis. So, data visualization in general, human-computer interaction in general, is all about augmenting people. Technology is about empowering humans. So, a shovel, for example, is a good way to dig, much better than hooking with your hands, with a stick. And an excavator is an even better tool. Of course, this idea of intelligence augmentation, you can extend that to show how technology can extend people's abilities to process information and reason about complex problems. This exoskeleton is another even more superior way, of course, of extending our muscles, our abilities to dig and lift and do things that we can't do. And similarly, of course, data visualization is all about extending people's abilities to think and reason about data. This idea of augmenting people's intellect is not new. It's been around for as long as there have been digital computers. So in the 1950s, for example, Douglas Engelbart, also with his famous mouse there, and you have to remember the mother of all demos, where he showed a lot of these ideas that are today's computing interfaces. He said that it's all about augmenting human intellect, increasing the capability of a man, addressing complex problems. That's the essence of computing. And that idea has persisted through the last, decades since digital computers were around. That's our side of the fence, those of us that do data visualization. Steve Jobs said that a computer is essentially a bicycle for our minds. It's not a car, it doesn't replace our muscles, but it extends our abilities. And of course, Don Norman, cognitive psychologist at UCSD, talks about things making us smart. So what I said at the beginning was that I've had a bit of a fear because as a data visualization person, I see myself in the IA camp, intelligence augmentation camp. But there is this other camp, the AI camp. And you could think of them as being separated at birth because the AI side of this equation came about the same time, in the 1950s. Digital computers were becoming a thing, and the idea of artificial intelligence was coined in the so-called Dartmouth seminar. For example, John McCarthy wrote a workshop where a bunch of AI pioneers spent a summer thinking about and defining this usage area. The basic idea, of course, is to achieve the efficient use of computing, but the approach is different. And my fear has always been that this other side is going to overshadow what we do in the data visualization field, in the IA camp. Some of these pioneers, of course, Alan Turing laid a lot of the groundwork for this field. Alan Newell, John McCarthy, Marvin Minsky, these are all some of the greats that were part of these workshops on these ideas of artificial intelligence. And this side, of course, of the equation has seen, perhaps even more so than us in the IA camp, an ebb and flow. We have seen winters and summers of AI, where a lot of societal interest and funding has ebbed and flowed. We've seen manifestations of these discussions over the years in some of our conferences. This famous debate between Ben Schneiderman and Patty Mays from IUI 97 and CHAI 97 is interesting because Patty Mays is representing the interface agents, the AI side, and Ben, of course, very much so empowering humans, direct manipulation side. And in these, if you read the transcripts of these two debates, in the end, they tend to come to a bit of a compromise. They say that we should have increased automation, we should amplify individuals, but we should preserve their sense of control and their responsibility. We can't just offload accountability to an AI model. The person needs to be accountable. So this is essentially the type of picture we've had for the last more than 50 years. And if you're anything like me, you've had to have this discussion, maybe in presenting your work to colleagues in your departments that do other types of work that don't see the distinction. You have to explain, well, I'm on the left side of this equation, I believe in humans, AI is more about replacing humans. So it always becomes a bit of a fraught issue. And it's not always helpful. And it's not even helped by recently, of course, the AI side is receiving a lot of attention. I mean, all of society today, all of the funding agencies, is all about funding artificial intelligence, generative AI, of course, nowadays. We have also the side of this fence, the AI side of the fence, are not always good stewards of thinking of their successes. I mean, in 2016, Jeff Hinton, who's one of the Turing Award winners for deep learning, he said that we should stop training radiologists because in 5 years we're not going to need them. We need deep learning. We should stop them. We have enough radiologists. And now, just a few years ago, he said, I never said that. But if you go on YouTube, you see him saying just that. So this is not helping matters. Because there have been triumphs on both sides of the fence. IA, because there are humans involved, had some very early wins. I mean, we have graphical user interfaces, we have, AuGment is a form of intelligence augmentation. The World Wide Web, the iPhone, these are things, because there's a human serving as the glue, doing the decision making. We're enabling and then augmenting their intellect. There have been great triumphs. But perhaps because it is so commonplace, because it's humans, it doesn't get the same fascination out of media and society and individuals. And on the other side of the fence, the AI side, of course, there have been a lot of setbacks. There have been summers of AI that then led to unfulfilled promises and succeedingly less and less funding. So it has not been an easy road on the AI side. Of course, now recently, in the last 10 or 15 years, we've seen this resurgence and a golden age of AI, where there's a lot of hype. And that's part of the problem, where essentially journalists many times are at fault for overhyping, saying, well, now the AI can take the bar exam, the AI can get into MIT, the AI is better doctors than real doctors. So that's not even helpful that way. So it's not a good situation to have these two camps where there's a lot of internal competition. Because there are setbacks. There are many setbacks when we try to put the AI in the driver's seat. First of all, of course, artists, visual artists, and of course also people who write are pushing back against their work being used to train these models. That's not really helping. And some of the most widely touted AI algorithms, like the Tesla autopilot, which maybe should never have been called an autopilot in the first place, have seen many very public and dangerous setbacks. And just about 6 months ago, when ChatGPT was being rolled out to run chatbots, you may have all seen people jailbreaking them. And this guy, for example, was able to get the Chevy dealer ChatGPT chatbot to sell him a Chevy Tahoe that's $76,000, but he promised to get to buy it for $1. So there are problems, there are risks, there are dangers. So for the last 5 years or so, we've seen a bit of a backlash where even folks from the AI side of the fence are recognizing that having a pure focus on just models and AI without human intervention, where there's a black box that takes all the decision and gives all the answers, can be dangerous. So in this op-ed in the New York Times, Fei-Fei Li from Stanford talked about creating an AI that's good for people, that enhances us rather than replacing us. And that's where I think data visualization can play a role. I'm not the first person to say that. Michael Jordan, not the basketball one, but professor at the University of California at Berkeley, about the same time said, well, we need well thought out interactions of humans and computers to solve our most pressing problems. We need the disciplines to study this. Well, as it happens, we have that discipline. Data visualization, HCAI, we've always been around, but by virtue of being such a large field, AI is becoming perhaps a little bit of an echo chamber, just as perhaps as we might be vulnerable, be doing as well. 2019, Stanford Human-Centered Artificial Intelligence Institute was launched, and my colleague Ben Schneiderman in 2022 wrote a book on human-centered AI. As I said, I'm not the first one to say this. These are areas where we need to put focus on, and visualization can provide some of that focus, especially visual analytics. So instead of having this bisected situation, we should be blending the boundaries between these two fields so that we can create this idea of human-centered AI and HCAI. Achieving these HCAI principles, Ben talks about AI-infused super tools that amplify, augment, empower, and enhance human performance. So in the last few months, my research group here in Aarhus University, only 2 hours away, I've been thinking about what this means, and that's what I'll talk a little bit about today. In particular, we took Ben's definition, those 4 verbs, and we tried to put some structure into them. What does it mean? I talked to Ben and I said, well, you came up with these 4 verbs. What did you have in mind? Is that a scientific definition? And he said, no, for me they were synonyms. So take this with a grain of salt. I still think it's valuable to think about what a human-centered AI tool could do for people. Because we could be amplifying existing abilities, magnifying what people already know can do. We could be augmenting by adding new capabilities that you did not have before. We might empower people to make tasks they were not able to do possible. And we might also enhance the quality of the work. So I think that these four verbs, there are a bit of synonyms and sometimes difficult to classify, but they are useful as thinking tools on what it might mean. The other side, of course, in a classic human computer interaction picture here, where you have an AI model on one hand instead of just a computer, and a human analyst. Another way to think about this, which is useful, is to think about the gulfs of execution and gulfs of evaluation. These 2 parts here, again, these are Don Norman terms, where the gulf of execution is how difficult is it for the human analyst, the human user, to enforce their intent on the AI model, to communicate what they're doing. That's an interaction problem. How do we create an interface where I can inform the AI model of my intentions? And the gulf of evaluation is very much a visualization problem, right? How do we create a representation of the state of the AI model that can be interpreted by the human side? So the goal of any interactive system or user interface, visual interface, is to shrink the gulf of execution, to make it as easy as possible to enforce my will, and to shrink the gulf of evaluation, to make it as easy as possible to interpret the state of the model. Now, of course, if I'm an AI person, And evaluating these things, I would look on the right side here. I would focus on the model concerns, things like precision, recall, performance, memory usage, the time it takes to train the model, the energy consumption to answer queries, and so on. But the focus of my discussion here are on the left side, human concerns. Things we may not think of really have to do with AI, but does when we think of the use of AI with people. We call them normally the FATE concepts of fairness, accountability, transparency, and ethics. I'd like to expand that even further. So thinking about things like not just explainability, but also understandability. So visualization can help both here just to create representations, but also make it possible for the target audience to understand, not just explain, not just visualize what's going on, but explain it so that it's understandable. Providing aspects of provenance, because we will increasingly see human AI authored artifacts, texts, or images, and just understanding the provenance, who did what, and how much did the AI do, and how much did the person do, is valuable. For those of you who are teaching, in universities or other levels, you probably have come across this already, that students are using ChatGPT to generate things. So the question is not whether they're doing it, but how much, and whether they checked what they generated. So I'm not going to talk about these in details, but if you think of these 7 concerns, these you can think of as requirements that we should keep in mind when designing human-centered AI. Because if you do, then you start getting things like agency, a sense of agency, trust in the system, feel a sense of the system has reliability, there's safety, and I have ownership of the artifacts I'm creating if I'm aware of what was generated and what was edited by me. Obviously, as a visual analytics person, just like if I hold a hammer, everything looks like a nail, my solution is to use data visualization. Because we can create, obviously, visual representations that can enable people to shrink these gaps of both evaluation and execution. So what I'm proposing, and my students work on, is this idea of visualization-enabled human-centered AI tools. There are many reasons why visualization is a good solution here. I think I'm preaching to the choir in many ways, but of course visualization is open-ended and data-driven. We facilitate a dialogue between the person and the machine or the model. We can externalize data, which makes it easier for us to offload memory and compute using our eyes essentially. And we get this shared representation that enables both the person and the AI model to operate in the same thing under the same circumstances. So taking the ideas of visualization, enabled HCAI tools, and applying them to those 7 concerns I had before, we get a bunch of design solutions here. How visualization designers can address, for example, fairness, transparency, explainability, understandability, accountability, provenance, and privacy. This is not an exhaustive list by any means. I'm sure all of you all have solutions that go beyond these in various ways. So I encourage you all to think about it, about this in these terms. We did some work just looking at a sampling of papers from the last 10 years or so, where it's clear that some of these papers, the ones that are highlighted, are work from my own group, that addresses things like amplification, augmentation, empowerment, and then enhancement. And then these are the other ones, things like fairness, transparency, and so on. So this becomes interesting, and it shows us that a lot of us, maybe not surprisingly, are already very active in this field. We're all doing AI, and for someone like me, like I said in the beginning, I started this project with a bit of a fear, right? That AI will overshadow our work and take over. What I'm seeing now is that there's a strong role that visual analytics can play in the future of human-centered AI. And I think also it shows that the whole community, even a large portion of AI researchers, are on board with creating these solutions. So let me show you a few examples from my own work just to reinforce and exemplify some of these ideas. And then I'll end this review with some design guidelines that we have amassed so far. So this first tool I'll talk about is called Sherpa. And the idea with Sherpa was computational steering. So we had a situation where we had a large data set from various domains. In this particular one, it was bioinformatics, it was functional genomics, and it was about doing analysis on genomic sequences. Running a brute force computation is impractical for real-time use. We could do it if we had weeks, and sometimes we did. We could, sequence a genome and run the computation in the background, and when someone needs it, it's already there. But perhaps I've just sequenced the data and I want to access it immediately. So in that situation, I might need computational steering to control exactly what is calculated first, because perhaps there are parts of the genome I'm interested in and parts I'm not interested in. Our idea was to just, instead of asking people to do computational steering using arcane tools and commands, we just created a visual tool where we had a data space view, the green field at the bottom here, and that showed the entire data set, and then we interpreted the attention, which part was the person focusing on through just navigational actions like zooming and panning, to control the priority for computation. It's fairly straightforward. So in the beginning, when I'm viewing the entire data space, let's say it's a genome, starts from 0, goes all the way to 100%, then the priority for the entire data set is the same. Everything has the same priorities. I'm going to calculate things from beginning to end. But then if someone zooms in on a part of this, shrinks the window, obviously the priority changes. So this part of the sequencing, or not the sequencing, but the processing that's being done on the gene sequence will be prioritized. So it's a bit of a just-in-time kind of analysis. Where the person is looking is where I'm going to be calculating. And as they pan, the priorities will change, so that other part will get higher priority. Perhaps will retain, so this the other priority will shrink or decay over time, because it's possible that the person will scale back or zoom back again. Our implementation here is called Sherpa Gene. It was integrated into a tool called EuroVA, which is an NIH project with some collaborators at the University of Maryland. At the bottom is the data space view. That's a gene sequence. The yellow field is where the window is focused, and the main view here shows the heat map of the calculations. So in the background on the server, this navigation information is being sent back to guide the computation. Yeah, so we did an evaluation. We found some interesting results here, that having control obviously makes things more direct for the user. Yeah, let's see. Second example is called Time Fork, where we looked at the stock market. And our idea here was to say, well, what if we could create a stock market browser where there's a support for what-if scenarios, where a stock market analyst can say, okay, I'm interested in these stocks. I think that Google is going to go up, and I think that Apple is going to stay the same. If that happens, how will the rest of the market respond? I have a video here to show. So what it does is the interface shows you a bunch of stocks, time series that you can browse through, and all you're doing is you're doing these direct manipulation actions to make predictions of how the stock will change over time, and also in value and time. So as you make these, you drop it, you can make additional ones, and then you push a button to get a prediction. You can create essentially a fork time. You can figure out different universes where time where the stock market might diverge in different parallel futures. Our UX Sense project was, again, ideas of combining AI models with interactive visualizations in a way that can make transparent what's going on instead of just a black box. So the problem we were attacking here is understanding user behavior, let's say user studies, where today there's a lot of video recording, audio recording, and also a bunch of UX specialists sitting behind one-way mirrors just studying what the person in front of the computer is doing. So that's a lot of video and audio data to analyze, which is very time-consuming. So our idea was to say, well, what if we could, instead of having so many resources spent on each session, what if we could just apply a bunch of various computer vision, machine learning filters on the video and the audio to provide a bunch of data to a single analyst, so that that single analyst can triangulate. And of course, maybe the individual computer vision filters are not perfect. Maybe they misinterpret sentiment, they misinterpret the reason for a click or what the transcript of what the person said. But taken together by providing all these rich sources that have been, we've imposed structure on them and provided an interface to browse them. That way, hopefully, the analyst will sort of be augmented and be able to do work alone that would require a whole team or a very long amount of time. So we ended up creating a tool called UX Sense that has, the primary thing here is this timeline browser. It looks a little like a video editor. It has a shared timeline where all the data is synchronized, and there's these swim lanes of data streams. There's several ones, you can scroll down. And it's all synchronized with a video playback on the upper left. In this particular case, it's just showing a video capture, but you can also switch to show a person sitting in front of the computer, and that person, maybe you see their facial expressions. Those facial expressions, I think, are what's shown here in the emotion track. That's essentially extracted to see whether they're frustrated or whether they're calm or neutral or whatever. There's a transcript from their Think Aloud protocol, things they were saying as they were doing this. And then there's a user annotation table, which is where the analyst can start coding, start marking parts of the interface. So again, it's all about triangulation and to provide all these resources that an individual on their own would be hard-pressed to do. And even if the individual filters are not perfect quality, because we all know that transcripts are not always correct if they're done by an AI. Emotions may also not be correct, but the hope is if you take this all together, then it will be valuable. And we did an evaluation with, I think it's 5 UX specialists from tech companies on the west coast of the US. And we were gratified that they didn't throw the tool out because they were positive, they were interested in thinking about things like this in the future. These are people who had no tolerance for automated tools, and they felt this was useful, potentially useful. Our next project here is some collaboration I've done with an English professor at the University of Maryland. And of all the faculty members and all the departments in a university, the language departments are the ones that feel of this threat of AI the most, I would say. So my colleague, an English professor, she's very concerned. She's an expert in literature on narrative techniques and things like that. So, and composition too. So these are challenges that they're dealing with, and they're worried, of course, about future writing or composition just being reduced to regurgitating old text that other people have written, and the loss of just original thought and voice with her students. In this particular case, we had a bunch of projects. I'll talk about 2. This is about close reading of a single book and this reading of many books. So we created a tool working with them to understand how can NLP techniques actually help rather than just become this threat. Because it's just like with any discipline, there's no point in trying to fight these things. We instead have to understand how they can help us and how we can understand them better. Because for these scholars, it is a big mystery, and it's also very threatening to a few of them. So for example, we looked at, in this case, we looked at just visualizing Alice in Wonderland. We did this for a bunch of different books, but we showed this to our colleague, we showed this to a bunch of literary scholars to understand what they needed. And I can show you a demo, I hope. Oops. It should be, yeah, so this is called, well, so this is portrayal. It shows, let's reset the, shows Alice in Wonderland here, and basically just all, on the right side here is the text of this book. It's not a very big book, but in this case, we are visualizing crescents. So it just says, in this for Alice, main character. So we see that she's present in every chapter from beginning to end. But we can start adding additional characters, and we can start adding additional NLP metrics like emotion, direct discourse, direct definition, and then just show these in this particular tool that enabled a literary scholar to drill down into particular chapters, to look at character development, relationships between characters, and so on. So what we found, of course, was that there was cautious embracing of these ideas, even if they are still scary, and also that there's a bit of a culture shift. There are those scholars who are very much traditionalists that don't want on any of this, and those that are embracing and understanding the possibilities. So, slightly encouraged by this work, we took another step on the scale here to create a tool called Hallmark. We just presented at the CHI conference a couple of weeks ago, where we wanted to see how can we support co-writing between an AI and a human. And this is an area that is very fraught for a scholar, of course. And our goal here is to say, well, it's inevitable that students are going to write. We can't stop progress. We can't make ChatGPT not available for students. So the question is rather, how do we try to make the co-writing, the prompting and the co-writing process more open so that it's clear to the teacher, and the students can also be open of what they did themselves and what have they checked and what is entirely written by the tool. So this Hallmark tool is all about maintaining the provenance of what was produced by the LLM or the human and what has the human edited. So it's essentially a way to visually see the revision history of a document. And of course, in the current case, this is just design, point design, but perhaps we want to think about these tools in the future where the changes are clear. There's no, you can't modify, you can't hide what's going on. So yeah, I can show you a brief demo here. I think I'm struggling. I think there's a connection. Yeah, still trying to do. I think there's a connection somewhere, maybe an API key that needs to be updated. But the idea is you have text that you're writing, you have a prompting interface with some pre-selected prompts, and then there's a timeline that clearly shows what you were writing, what the AI has generated, what you have edited, and that can also be highlighted in the document itself so that it's clear, so you can see, how much impact has there been of the human involved. Okay, so let me wrap up with some design guidelines from these examples and others in my group. Again, these are not exhaustive in any ways, and I'm sure here, at the EuroVA workshop, a lot of visual analytics and the best papers as well are all about embracing machine learning. So I think there's a lot of ideas here that we should be combining. Some of the design guidelines that we've come up with was to think about, first of all, that simple visualizations in many ways are more than enough. We want to avoid the friction of learning very complex visualizations. And remember the AI specialists or the domain users that we're trying to attract with these tools are not visualization experts. So we shouldn't be doing things that are very complex. We should be doing things that are understandable, simple visuals. Visualization in general has a tendency to do toy problems. Tamara Munson wrote about this 15 years ago. Don't use toy problems. I've seen other people say this. Don't use the CARS data set. I've done that plenty of times, so I'm not here to point fingers. But we should be tackling these human concerns directly. Don't beat around the bush. Address challenges like these human privacy, accountability, transparency, explainability concerns directly. And then the third here is on the power of interaction. Often overlooked in visualization, we tend to focus on the visuals, but the interaction is what puts this in people's hands. That's what closes the loop. So it's not just enough to have visualization. It's the glue that make the visualization and the visual analytics workflows work. And it should be focused to shrink this gulf of execution. A main philosophy for visualization-enabled human-centered AI tools is that we show users the data. We show what is happening. We don't tell them what to do. That's what a lot of automated tools on the AI side of the fence go wrong, where we try to take over the car entirely and we have an accident as a result. So it should still be all about empowering the human, even if you blend these two fields. And we should avoid machine decisions that are not safe. There are many that are safe. What is the next Netflix movie I should watch? That's a relatively safe decision, but there are those that are not safe that we should be mindful of. And of course, using real data, using real tasks are definitely things to do. Okay, that was my talk. Thank you for your attention.
Niklas, thank you for this lovely opening talk to this conference here, this workshop, of course. And so I think you were begging for this question, which is now we have HCAI, what's the difference to visual analytics, right? Some 20 years ago, we sort of said the same things, let's include models, blah, blah, blah. Let me throw out my hypothesis or the way how I think it, and I would love you to comment on that. I think for me the main difference is back in the days we usually started with data, and the goal was also always try to understand data, exploring data, and now it's switching the tasks. So it's the tasks are writing, it's riding your bicycle, and we use data and models to support that, maybe not riding a bicycle, but writing text or that. Is that the main difference, or what do you think?
I think that's a fair assessment. I think, as I said, I started out with talking about a bit of a fear. This was a bit of a journey of self-discovery for my own research, realizing that what we had done already was human-centered AI. So I'm saying, I agree with you, definitely. I think perhaps what we have to realize, I think it's a tough fact for many of us to realize, is that we are tool builders in this community. And we're not the ones, maybe that will cure cancer or whatever. We build the tools that will make that happen, hopefully. And so what I mean by that is people don't wake up in the morning saying, I'm going to visualize data. I'm going to analyze data. Instead they'll say, I want to do X, I want to do a real task using, hopefully, our tools along the way. So perhaps this is a good development that we're now talking about the task that we actually want to do, rather than focusing on the data, which essentially, it's not a byproduct in any way, but it maybe should not be the focus.
Thank you.
Right, thanks for the keynote. I want to also continue challenging a little bit on this notion of intelligence augmentations versus AI and how we position ourselves as a community. How do you think we should make ourselves more present as a visualization HCAI community? And also, how do we make our research more rigorous so that it's accepted and adopted by other communities? Because I feel like we've built a lot of tools, it's very nice and so on, but going out there and talking about this research field is very challenging at the moment in order for it to be accepted.
Absolutely. I mean, to some degree, we are the ones with our hats in our hands approaching this giant AI, the field of AI. So it's not enough to build it and say they'll come, because they're not going to come. And you saw Michael Jordan's comment. It says, we need this discipline, and if we don't do anything, they're going to build their own discipline. I think it's already happening. That doesn't involve us at all. So it's not about we're going to sit here and think that they're going to come eventually and ask us, like, you know, the poor princess sitting in the castle, no one asks her because you don't think of her. They don't see her. So I guess we have to approach these fields. We have to publish our work there if we can. And you know, you say, how do we get the kind of rigor that is necessary? Yeah. I don't know how to answer to that. I think that there are, I mean, I've seen publications from a lot of us here in this community that are starting to appear in some of these venues. I think we can build on that. We can also build on the fact that even some of the AI experts are pushing for this, and perhaps we can provide some of the answers.
Jean Lamia.
Hi, I'm Niklas from EuroVA. Thanks, Niklas, for the talk. It was really interesting and great. So I just wanted to disagree with you because everybody would be agreeing. On this stuff about explainability, I'm a bit fed up of it because I think that's how AI is hijacking visual analytics to work for them. Like open, show me the engine and help me debug the engine. Where are the debuggers for the AI? I think it's fine to be debuggers for people.
Yeah.
Maybe even Vsoft trying to help people debug their programming languages. Okay, fine. But to me, I don't think that explainability is that much of a problem. When you go to a garage and you have your car fixed, sometimes you ask, what did you do? Sometimes somebody answers in a very accurate way. Sometimes they just fix it, it works, don't worry, and you're happy with that. And same thing if you go to a bank and get a loan, you're happy with the loan. If it's denied, it's denied. If you ask, explain, they can do whatever they want, but how can you check? It doesn't really matter. So, and if you go to a doctor, you have a serious illness and you ask to explain, even the word you won't understand the word. So, to me, this explainability stuff has been overhyped because of people like us wanting to be in the AI domain and helping them, and I think it's fair, but I think this is really overhyped. I don't know what you think about it. I have a lot of questions that I want
Yeah.
to
I think it's a fair point, but we're used to this, right? We're used to real scientists saying, oh, we're doing all the science, and at the end we'll get a visualization person to explain it. And we've been fighting for the from the beginning of the field to be part of the process earlier. So this is not new, I think. We're trying to become part of the debugging or the analysis, and not just the pretty pictures at the end, is a perpetual visualization problem that I think a lot of us are struggling and fighting. So I agree with you, and that's why we also added this idea of understandability. I mean, you're right, maybe I don't want to understand exactly how my car engine works or how my sickness is progressing and has been treated, but providing an understandable that is fit to the target audience is part of transparency to understand what's going on.
Yeah.
So that would be my first answer.
Hi, Niklas Mahiar, University of Massachusetts Amherst. Thank you so much for the timely talk and the interesting design guideline about show, not tell, which definitely resembles with me with the work that I presented here 2 years ago about, visualization for leaving interpretation for the human rather than prescribing anything in our visualization. But I want to get your thoughts on when it comes to the general public. We tend to think about storytelling, annotation, bringing the message up front, and basically prescribing with our visualization what to look at. But like when you're leaving it open, we're just showing what are the tensions there.
Yeah, I mean, I think there's value in both creating stories where you can follow and I don't know, massage the story or what you're trying to tell someone based on their capabilities. But the real power of visualization to me has always been the ability to generate, visualization is all about exploration, getting questions or hypotheses from the data where I can see it, rather than confirmatory, where I have to formulate my questions in advance. So I don't know what exactly my answer to what you're asking. I think that for an audience that's not very well versed in visualization, we may have to create more easily digestible stories, or you have to tell them what they're seeing, but like data-driven storytelling, where you can still understand the context and confirm for yourself that the answer is valid. But creating visualizations where there is no real, I don't know, call it prepackaged message, is where our field shines.
Thank you for the wonderful talk, Claudio Silva from NYU. I think I have some similar, maybe, concerns to Jean Daniel, but also I think some slightly different ones. So one of the things that, I've been teaching a course on visualization for machine learning for about 4 years. And initially I started with covering a bunch of papers that we, the visualization people, wrote, right? But lately, actually, what I noticed is that most of the really relevant literature were created by the machine learning people. So if I look at, there's like this, I think, 2014 paper by one of my colleagues at NYU on visualizing, convolution networks. That thing has like, I don't know, 15,000 citations, maybe 20,000 citations. Then if we look at Teasney, okay, again, it was from Jeff Vinton, is another one of these, like, and so somehow I wonder why we don't seem to be, if we are the experts on visualization, and we are the experts on interaction, right? I would expect that by now we would have learned to actually have an impact in the field, right? But for instance, you were talking about these AI assistants. It reminds me a lot of, I think it was last year, interviewing this person called Mina Lee. She's working on these, AI assistant, merging kind of like HCAI with but they have a different perspective somehow, right? So Niklas, what do you think we need to do to close the gap so that the tools that we develop are truly adopted, right? Somehow, I'll add one more thought. I know that this is a long rant. Is that maybe the way that we've learned to write our papers, the design studies, doesn't actually fit. Like when an ML person is reading our papers, that might be like, oh, this is really not relevant, right? So like I know it's a bunch of questions here, but the question is how do we make ourselves more relevant in this space?
I think it's a valid question. I think it's what Mena said too. And I don't know if I have the answer, where my answer is that we can't stay in our echo chamber. Ours is much smaller than the AI echo chamber. So we're going to have to approach them, because it's not enough to build it, they will not come. But I am not the right person exactly to say how that is done. This has been a journey of discovery for me, and it's still ongoing for me. There are people in this field and this workshop, I think, that also have better answers, and hopefully we will use some of that this week to answer that question. But I think that for me, I don't have a direct answer to say. I think we need to approach them. We need to find ways to explain our work in the language of these fields. And you're right, that things like a lot of the qualitative research, a lot of the design studies, those things are not going to be seen as relevant to these hardcore computer scientists. A lot of them are hardcore computer scientists, statisticians, and so on.
maybe to put a hypothesis out there, you were talking about the gulf of execution, the gulf of evaluation. Most of your work is leaning either towards the one, closing the one, or closing the other.
Yeah.
But maybe if we have work that actually tackles both of them at the same time, we could have like a Doug Engelbart moment where that actually works, not only to interact with, but also to interpret afterwards.
Yep.
Just as a hypothesis.
Yeah, I give the challenge to everyone here to come up with that. I think it's great. Yeah.
Great. More questions? Yeah, in the back. Mike is coming.
Thank you so much, Gabriela Morgenstern, University of Zurich. Hi, Jürgen. Okay, so I have no, I think, active pushback to give, but I am really curious because you're doing a lot of visualizations that look at annotating like for model use or helping users interact with models. What are you doing on your end to assess like how impactful that interaction is for that end product of having a more useful model or being able to empower users better with the model? What are the metrics that you're kind of aiming towards there?
So most of the projects that I presented have some form of validation. Often it's a user study, and often there is some baseline condition where the interaction with the AI model or the visualization is not active, so that we have some comparison. But by the nature of a lot of the questions that we do, of course, data visualization research, these are going to be high-level things that are hard to do quantitatively, so there's going to be qualitative studies in various forms. So that's what we tend to do in my group. We tend to pitch the system with the particular assistance, the AI model, whatever, inactive, and so it's the same system, so we're still comparing more or less apples to apples, and one where it's active, and then we see the performance. Yes.
Have you tried setting it up as like a control intervention condition study to kind of borrow from a more medical perspective?
So when you say that, do you mean that the same person after a while gets an intervention, and then you see their performance?
Yeah, or so we were thinking of something similar for like a labeling interface that is meant to improve model performance and classification, and thinking of having two groups,
Yeah.
One exposed to like the classical workflow of labeling, Song's tool, and one exposed to our model, and then looking at like related outcomes across both groups and just seeing what the improvement is.
Yeah, we often, yes. So I think that's a good way to do it. If you have a curse of knowledge, of course, because if you're doing the same task and someone starts with the tool's assistance and then with no tool assistance, they will have learned something. So you have to probably like balance the task or something, or data set or something, so that it will not influence. But yeah, that's common. You know, we try to do a protocol like that. Yes. So especially if it's the same person, but with and without the interface.
But despite that, you still find there's like a gap in reportability between our field and ML, for example. Because NERDS does have visualization tools presented at it, so.
Yeah, I think there's a gap, yes.
Okay.
I'm happy to talk about this offline.
Definitely.
Yeah, Shannon, yeah.
Yeah, me again. You don't want to take the whole thing, but one thing that I want your head on is that I think we have another problem coming now is the fragmentation of our tasks due to AI, because now many of our tasks, just like writing, can be solved partially with AI tools. And we see the whole process, all the processes being split into small subtasks, where some of those small subtasks are managed by AI tools, but the overall big task is now a complete mess. And in particular, we don't have this feeling that it's over, it's done. We start something, then the AI comes in and changes, and you can change this paragraph like this, and you can change it like that, and then the new tool comes, change it again. And before that, we would do things from A to Z, and we've had this feeling of completion, and it was done. We don't have that anymore. So don't you think that this problem of fragmented tasks, because of the fact that one fragment can be, or many fragments can be done with AI, but not rethinking the whole process is also a major problem coming day after day more and more?
I agree. I think there's definitely a risk. Yes. So that's partly why in this most recent work I showed Hallmark, we were focusing on provenance so that you have an understanding, a picture even, timeline of what has happened. And even if you didn't do all of it, then at least you can see, you get a picture of what's happened. To provide, to close that loop to some degree. But I think, I definitely agree with you. I think it's the way, the current model of these AI tools for, let's say, data analysis, right? Upload a CSV file to ChatGPT and analyze it, and then I take over. And then it takes over, goes back and forth. It's precisely the type of thing a human is bad at, where it's like the same thing when you're using an autopilot to drive, and when the AI gets in trouble, it says, okay, I can't do it, you do it. And that's exactly when a human is not good at sitting there being attentive if they're not involved the whole time. I think that there's some of the same phenomena involved here. If I'm not involved in the data analysis the whole time, I don't follow every lead, then I'm going to be detached, and I'm not going to be comfortable with the data analysis. So yeah, I don't know. I mean, like I said, in this Hallmark tool, we visualize the provenance. We show when you have touched the sentence, that it wasn't entirely generated. You looked at it and maybe even edited it. You can see that. So perhaps that shows you then that you have a sense of ownership, and you feel that I can trust what I did, that it's mine, or at least if it's not entirely mine, I have checked it. But I think that's going to be necessary for data analysis too. Yes.
So we've been talking so far about AI in early model way, and there's obviously been a lot of different models that you can think about, so generative AI and predictive models and things like this. So I'm wondering, with these design guidelines that you've been discussing, how you see those maybe changing slightly as you think about these different models. I'm interested in what you think about this when you think about AI more finely.
Yeah. So the question is about whether the design guidelines apply to all of these different types of models that exist out there. Part of what we realized, of course, in this work is that what we call AI is a huge topic, and what the society talks about is AI is normally generative AI, like the tip of what's going on. And you are absolutely right that these design guidelines are very general, and we wrote them so they could be generally applicable. Off the top of my head, I don't have specializations for what that means for particular models. But I agree with you that this is not an exhaustive list. It needs to be expanded, and perhaps that's a way to make ourselves useful too for the AI field.
I wanted to push back a little bit about this whole discussion on using generative models and visualization tools. So since we have a lot of issues with these models, the linguistics community is looking at a lot of different issues with hallucinations, biases, all you name it. Do you think, with respect to that, is there a good and a bad way to do visualization research with respect to generative models and language models?
Yeah. Good or bad way? I mean, I think visualization perhaps has a good, yeah. I mean, look at all my papers. But, I think perhaps visualization may have this opportunity perhaps to show uncertainty more so than if I generate something with ChatGPT, it looks very authoritative. I get text that's nicely formatted, there's no spelling mistakes, and there's a paper that I haven't seen before, but I'm going to copy and paste it into my paper. But it might be a hallucination. So it looks very believable because they were trained to be believable. I don't know, perhaps by showing something about the certainty, the temperature of the model, these things could maybe be added to a visual representation to hopefully entice the person to think critically about what they're being seen. I think that's part of the interface with ChatGPT is a black box. But what I'm saying here, what we as visualization people, or visual analytics people can do, is that we can add additional context, some insight into the model, how secure are there, how secure, how certain, what's all these things.
Angelos Gonzalez, Utrecht University. So I'm wondering, now that we're discussing, do you feel more and more more skeptical again about your fears you mentioned before, and maybe like a more serious follow-up question isn't it kind of exhaustive to have to convince so many people, like the AI community, like the users that have to collect the data, to convince everyone that we should somehow collaborate to design the tool or something. So is there any better way of doing that? How can we approach these problems?
So I think my fears were allayed by this work. I think I've heard this from several people too. And Michael has said that isn't visual analytics, isn't that what this is, human-centered AI is to some degree? And I think what I realized was that, yeah, I've been doing this thing all along for the last 10 years. And so it is not this big, great fear that we have to have. That we are already doing it, doesn't mean we can't do more of it or do it more informed. It is definitely exhausting to be a visualization person now that the balance has changed and we are not getting the same kind of funding that people that do AI is getting, and we're not getting attention, and we feel like maybe we're standing outside their echo chamber and not getting in. It is definitely exhausting. And some of you probably who are looking for research funding and so on might feel this, Microsoft is now an AI company. One of my colleagues there said, if there's no AI in the research, we can't collaborate. So yeah, it does suck a lot of the oxygen out of the room if you're not doing AI work. Obviously, pragmatically, that's part of the reason I'm talking about this, because we all can contribute to this field.
Last question. So it's me again. As Sean Daniel also asked 2 questions. So this is a short one, but let's see. So I'm coming back to the point that Claudia made, and you also made before, Mena. So the tricky thing is really reaching out, right? It's so easy to say, hey, we need to go to this other community and convince them. I remember 15 years ago, we said, let's go to the statisticians. No one is talking about them anymore. Anyways, but sorry, but now I see the same problem. I think pragmatically, the real problem is that if you want to live in 2 communities, it's really gonna energy taking, right? I know a few people might be raise your hands if you're on the IPC of, say, NeurIPS, and if you're on the IPC of ICML. Okay, so there's very few hands, right? And that's look how tired Mena looks. Sorry. No, it's really, I think there's a problem in our system, right? Because we're all overloaded with work. How can we make that happen, right? It's an old problem. I know, okay, it's not an easy question, but maybe you have ideas on, how to free up people, and it's, that's an overloading career building system, publish or perish versus, academic communication, and what is the community reach? Do you have any short thoughts? I think otherwise I would kill you.
I don't have any short thoughts. We can talk longer thoughts later. But I can say one thing, which is that visual analytics folks are tool builders. I said this already. We've done this before. We do this all the time. Most of the data we visualize, it's not our own data. It's someone else's data. So perhaps optimistic end note would be to say, you're all working with domain experts. Maybe we should view AI as a domain that we can just work with. We know how to do it. We can do it again.
Besides that, methodology for the rest. No, sorry.
All right. So, thank you very much for this one-man panel.